Our next unit is about graphing quadratic equations, and in this lesson we're going to look at the two basic forms of a quadratic equation and the key features of the graph. First, let's look at the two basic forms of a quadratic equation, standard form and vertex form. Standard form is sometimes called general form, and the equation looks like this: y equals ax squared plus bx plus c. If you remember our lesson with the quadratic formula, you'll notice that this is the same form we use to identify a, b, and c, except that instead of being equal to 0, it's equal to y here. Vertex form looks quite different. Y equals a times the quantity x minus h squared plus k. This form does have an x, y, and a just like standard form, but the h and k tell us something about the graph, as we'll see later. Now let's look at the graph of a quadratic equation, which is known as a parabola. A parabola is a curve like these graphs show. It can have a low point and open upward like the one on the left, or it can have a high point and open downward like the one on the right. There are four key features of the parabola. First, the axis of symmetry is an imaginary line going right through the middle of the parabola. We call it the axis of symmetry because the parts of the parabola on either side of it are mirror images of each other. This means the parabola has symmetry. Next, we have the vertex. This is the point on the parabola that is the highest or lowest, and the axis of symmetry goes through it. We usually use the letter V to label it. If the parabola opens up and the vertex is the lowest point, we call it a minimum point, or min for short. If the parabola opens down and the vertex is the highest point, we call it a maximum point, or max for short. The third key feature is the y-intercept. This is the point where the parabola crosses the y-axis. Finally, we have the x-intercepts. These are called x-intercepts because they are the points where the parabola crosses the x-axis. We often use z's to label them, because in an equation the x-coordinates that make y equals 0 are known as zeros. Parabolas can be found in many places in nature. The path of water falling through the air, a spider web drooping under the weight of the dew, or a rainbow across the sky. Men have also used parabolas in architecture and design. The arches supporting a bridge, the hill of a roller coaster, a satellite dish, or the Gateway Arch in St. Louis. There are a few differences when we try to graph parabolas using the two different forms. The next two lessons will illustrate them.